Professor Barry drop an apple at time, what time? T is equal to 0. And the apple travel at the distance dt is equal to 4.9 t squared. You want to find the apple travel between 2 seconds to 2.5 seconds. That part does make sense, right? Right? Not from 0 to 2 seconds. You can find from 0 to 2 seconds, can you? Yeah, sure. The same way. If you can find how much it traveled from 2 to 2.5 seconds, you can find how much distance the apple traveled from 0 to 2 seconds. Right? Okay, sure. So how much distance apple traveled between 2.5 seconds? Okay, so S T final minus S T initial. Alright, S is 4.9. You can use any variable you want. There is nothing special to S. T final is 2.5 second square. I'm using the function. That's okay, right? Using function is okay, right? Minus 4.9. Right now you do solve it in your notebook, right? And later when you finish solving in your notebook, then you grade it. Okay. What should I put over there? 2 squared. Now can someone give me this one, please? 4.9 times 2.5 squared is how much? 6.25? Yeah. 6.25 minus 4.9. This one I think I can do it. Now 4.9 times 6.25 is how much? 30.625 minus 4.9 times 4 is very close to 20. How much? 19.6. What is the difference? 11.025 meter. If someone write 11 meter, that's also fine. If someone write 11 meter, please, be kind. Okay. Next part. This part, now don't grade now. Just write it down in your notebook. That's what we do every day. First you understand and then grading. The quiz grade as you see is very friendly. Very friendly. Okay. What is the next part? Next part is the velocity. Average velocity. Average velocity between what? Average velocity between 2.25, between 2 to 2.5. Does that make sense? There is average velocity between 2 to. This is an interval, right? Mm-hmm. Can you find an instantaneous velocity between 2 to 2.5? Or 2.5. Can you find an instantaneous velocity in this interval? No. Instantaneous velocity doesn't exist in an interval. Does that make sense? Instantaneous velocity only exists at one point, not 2 point, not interval. Does that make sense? Okay, now we are trying to find the velocity. How can we find the velocity? You're going to find the velocity same way last time. Velocity is distance over time. So velocity is d final minus d initial over t final minus t initial. So velocity is d final. What is d final? S t squared. What is it? You're gonna have to write this one. So 4.9, t is how much? 2.5 square minus what? 4.9, then what? 2 square over what? 2.5 minus 2. On the top, what are you going to write? Right. 11.025. On the bottom, what are you going to write? 0.5. Yes, sir. Oh, the statistics?
Yes.
Okay, thank you. On the bottom, what are you going to write? 0.5. So what is the average velocity? .05 meter per second. If someone write 22, that's fine. That's more than fine. Yes. Huh? Did you get 25 or what is it? 22? Okay, that's fine. Yeah.
So what in the question it's saying that find instantaneous velocity number 3.
Yeah, that's true.
So you finding it's for number B or number C?
This is 2. As I said, you cannot find instantaneous velocity in interval.
What does it mean by D by W? It's between?
It's between, yes. It's between, yes. Even if I give you 2.2.1, you cannot find an instantaneous velocity. Okay. Does that part make sense to everyone? Yes? Okay. Okay, now last one. Last one you can do 2 approaches. I don't really care which approach you did. You can do numeric. Numeric means this way. T goes to 2 from negative side and T goes to 2 from positive side. This is the long way. Does that make sense? The way we did it. This is important, very important. Maybe we can. How many people have calculator? Oh, so many. Okay, all right. So let's do this way. Some people missed the class last time. So 2. This is 2. Give me some point. What is this point? 1.9. What is this point? Very nice. What is this point? Nice. I like that. What is this point? 2.01. What is this point? Very nice. What is this point? Okay, now instead of doing it by calculus, this is also calculus, you're going to do this way. This is called numeric approach. Numeric. Okay. Let's see the function. Let's write down the function here on this side. What is our function? 4.9 t squared. So let's do this one. 1.9, 1.99, 1.999. Please do it and then report me. And then you're going to do here t is equal to 2 plus. And then you're going to write 2.01, 2.001, and 2.0001. And after finish this one, we of course gonna do it traditional way. Traditional way. Correct. So everyone please do that. This is very important. Do it in your notebook. Grading is something optional. You can do it later. .79. 6.
Second one is 19.619.
619.
Third one is
Oh, I'm sorry. 19.796. Second one is
19.619.
619.
Third one is 19.601.
601. Okay. All right. So let's do one more here. 1.9999 2.00001. Okay, just to be 49, yeah.
So you get 19.598.
Okay, great. And then
And then you get 19.6001.
so what do you conclude? 19.6. So the limit is 19.6. All right, now we're gonna do at limit is 19.6 mean what? The instantaneous velocity when time is 2 seconds, the instantaneous velocity of the apple is 19.6 meter per second. That's a lot of velocity. Does that make sense? Now we're gonna do the traditional way using the power rule to check our answer again. What I have to write, dt is equal to 4.9 t squared. dt d 4.9 t. Okay, so dt is 4.9. This is 9.8, right? 9.8 t. So at 2, 9.8 t is how much? Is it exactly 19.6? This is magic, right? It's not something else. It could have been 19.7, but it is not 19.7. It's exactly 19.6. We did not do any manipulation with anything. It's just in front of your eyes.